Welcome back. After understanding the phase diagram of water in 3 dimensions and also in 2 dimensions, as I said earlier, we will normally refer the PT diagram and the PV diagram. Let us now see some features of this phase diagram. So, features of the phase diagram, and what I am showing here is a pressure temperature diagram that we have just seen. So, you can see solid, liquid, vapor region here and also gas in this region. So, projection of the state space of water on the PT graph, that is what we are seeing here. What you see here, all the phase transition line, solid to liquid phase transition line, liquid to vapor phase transition line and solid to vapor phase transition line. We will more concentrate on these 3 different phase transitions lines now, and therefore, I can remove all the colored part and concentrate only on this Y that you can see from here. Alright, this is the Y which shows actually 3 lines which actually depict the phase transition line, and this is normally also referred as crooked Y because this Y is little tilted, it makes some angle and therefore what we call it as crooked Y. What you see from here is therefore 3 phases. This Y actually divides this region in 3 different phases. We got a solid region here which is a solid phase on this side, then we got a liquid phase which is inside this Y, as you have seen already from the PT diagram earlier, and what we have is a vapor region here on this side. So, what we have is a SLV, 3 different phases in these 3 different regions made because of this crooked Y. Now, we can notice various features from these phase diagrams. What are these features? What you see here is a green line which is what we call as liquid vapor saturation line, because you encounter this line while having a phase transformation from liquid to vapor. So, on this line we got liquid and vapor in equilibrium or coexisting together, and that is why we say it is a liquid vapor saturation line, many times also referred as LV saturation line or LV line also, alright. So, this line actually goes from triple point to the critical point, alright. The LV line, the LV saturation line goes from TP to CP or triple point to critical point. Then concentrate on this line which actually depict the phase transition from solid to liquid region. This is what we call as solid liquid saturation line. Again we here say that solid and liquid coexist here together, they are in equilibrium, and that is why we call this as SL line or SL saturation line. And the third line of this Y is this leg, which is what we say as solid vapor saturation line. Again at lower pressures and lower temperatures, if we increase the temperature here, we go straight away from solid to vapor region, and this is SV line where solid and vapor stay together, they exist together, they are in equilibrium over here. What you also see in addition to these 3 lines are 2 major points. One of the important point is triple point. We had seen this point in the PT diagram when we saw this 3 dimensional phase diagram of water. This is a very specific characteristic of water. It exists at given temperature and given pressure. So, it exists at 0.01 degree centigrade and at 0.000617 MPa. So, this point is absolutely fixed. It is specific property of this water where SLV, solid, liquid and vapor are in equilibrium, they coexist at a given pressure and temperature. If either of these point changes, it will not be a triple point anymore. The other point what you see is a CP or the critical point. This critical point also is a specific characteristic of water which exists at 22.064 MPa pressure and 373.946 degree centigrade temperature. You can see that this phase transition line or LV phase transition line exists only from TP to CP, and beyond CP there is no such phase transition line, which is what I talked to you in the earlier phase diagram when I showed that we have got a liquid to gas transition that is happening, but then we do not have any phase transition. Whenever there is a phase transition across this LV line, there is a latent heat is involved because there is a phase transformation from liquid to vapor, and this is also referred to as latent heat phase transformation, that also exists across this SL line, that also exists across this SV line. But if the pressure is more than critical pressure, we do not have such latent heat phase transformation existing anymore. Thank you very much.